Okay, this is chapter 17, section 3. We're going to talk about equilibrium constants. In this video, we're going to do about half of this section here. We're going to do the first two objectives here. We're going to determine equilibrium product concentrations, equilibrium concentrations of some reactants and products, show you how to do that. And we're going to talk about something called the solubility product constant. We're going to leave the common ion effect till the next video. So we're just going to talk about the solubility product concentration constant and these equilibrium expressions, how we use those to calculate concentrations. Okay, so if we have an equation like this, we usually know the equilibrium constant, right? And if we do know that, so we have all these things here and we want to find the concentration of hydrogen. So usually we know the equilibrium constant and we want to try to find this concentration. So the first thing we need to do is set up the equilibrium expression. So remember, it looks like this. You got the equilibrium is the product's concentration raised to whatever this coefficient power is times the sulfur concentration. Those are the two products. These are multiplied together, divided by the reactant concentration, and then that raised to that coefficient. So that's where we get that from. A little review there. Okay, so we want to find the hydrogen concentration, right? So to do this, what you should do, and which most of you don't, is isolate the H2 variable in this equation. So to do that, we'd multiply by H2S squared and divide by S2. Okay, so it should look like this. Most of you skip this step and you plug in the numbers and you do stuff. And for some of you, it works okay. And others, it doesn't work okay. You don't really, you try to skip a step and it makes it worse when you get it wrong. Okay, so, but if we get this right, we can easily plug in the numbers, and you should practice this on your calculator. Make sure you can do this on your calculator, right? Some of you are not that great with the calculators. You make mistakes or you don't know how to put in the squared or divide by things. So check this, make sure you get this same answer on your calculator. Okay, but we're not quite done here yet, right? So we got to get rid of this squared part here. So obviously to do that, we're going to take the square root of this number. So the square root of 001423 is this one. So the concentration of hydrogen is 0.0377 moles per liter. And moles per liter are the concentration that we most often use in these situations. So moles per liter, that's molarity. Okay, so we can set up an equilibrium expression when we have a compound that's sparingly soluble. That means it doesn't really dissolve that well. It's not like salt or sugar that always, almost always dissolves or dissolves readily. So we can get a solubility product constant similar to the way we did the equilibrium products, equilibrium expressions. Okay, so we're going to break the compound down into its ions and then multiply those concentrations together times whatever and raise them to whatever exponent. If it has a coefficient in the equation when it breaks down, we're going to raise that concentration to the coefficient, same way we did with the equilibrium expressions. So an example here, barium sulfate dissolves in water. We get these two ions, barium and sulfur, right? There's no coefficients here. So the equilibrium expression is just the concentration of barium times the concentration of the sulfate, and it's just 1.1 times 10 to the negative 10. That's what it is. We get these from tables, right? So most of the time we know what the solubility product constant is, and we're trying to figure out what the concentration of one of these elements in here, one of these ions is. So we have a little more complicated one with magnesium and hydroxide. What does that break down to? Well, on this side we have one magnesium and two hydroxides. So it's going to break down to three things, right? One magnesium and two hydroxides. So when we write the equilibrium or the solubility product constant for that, the expression is the concentration of the magnesium times the concentration of the hydroxide. And since we have this 2 here, that concentration is going to be squared. And I just got this from from a table, right? This is where most of the time we get these are known values what the solubility constant is. Okay, we use this to figure out what the concentration of barium is when we dissolve it in water, right? So if we do that, we get equal parts barium and um, sulfate. Okay, so we put an X for barium, we put an X for sulfate. X squared equals this, so we take the square root of that and we get that. So the concentration of barium is 1.05 times 10 to the negative fifth. Okay, so that's a pretty straightforward calculation there. So you just have to recall that these two are in equal parts. They break down equally. For the magnesium hydroxide, remember it's this one thing breaks down into three different things, and the solubility product looks like this, with the concentration of the magnesium times the concentration of the hydroxide squared, and this is what it equals. Okay, but also remember from this equation, for every magnesium, we're going to get two hydroxides. So for whatever magnesium is, we're going to get twice as many hydroxides. And a lot of students get this far with the process, but then they make a common mistake here. They write this down just like it sounds, 2x squared. Okay, so they write down the 2 and then they write down x squared. But that's not what really happens when we do this. When we do this, we square the 2, we square the x, and it's actually 4x squared. Then when we multiply that by x, we get 4x to the third. Okay, so to solve this one for x, we divide both sides by 4. Okay, then we need to take the cube root of this number. Okay, so a little typo there. That should have been 10 to the negative 12. That negative 12 should have been an exponent. Sorry about that. Or the other way you can do it, this sometimes is easier. Sometimes finding the cube root function on your calculator is not that straightforward. It's buried in a menu somewhere. But the exponent function is usually readily available. And so you can take that same number and raise it to the 1/3 power is the same as taking the cube root. Okay, so you may have to put a parentheses around the 1/3 when you do that, but you can easily find the exponent function on most calculators. So we do that, we get x equals 1.1 times 10 to the 4th. Well, what is that? That's the concentration of the magnesium. Okay, so it's 1.1 times 10 to the 4th. Well, what about the hydroxide? What's the concentration on that? Well, remember, it was twice as many hydroxides as there were magnesium, so we're going to have 2 times whatever this number is, so we're going to get 2.2 times 10 to the 4th. Okay, so we're going to stop this video right here, and we'll do the second half of this section 17.3 in the next video.